Hello everyone, welcome to Elite Engineer. In this video, we are going to see how we can implement incremental and conductance maximum power point tracking technique in our buck converter. In the previous videos, we have already seen that how we can implement perturb and observe maximum power point tracking technique in buck, boost, sepic and zeta converter. So in this video, we are just going to see the incremental conductance. And we are going to see in the similar fashion like buck, boost, sepic and zeta. Now what I've done is the solar P panel consists of same configuration as of previous, which is a 301.928, which I've already considered. If you need the research paper for this, I'll just try to put the research paper on my website also in the description below. So what happened here is I'll just click on the plot and we can see here is I've already shown you in the previous videos also, like on 25 degrees Celsius in 1000 watts, I'll get the power that is a maximum power that is 301.928, right? And this is a maximum power point voltage and this is a current. This is a open circuit voltage and this is a short circuit current. Now what happened here is this thing you can just redefine based upon your ratings or whatsoever you want, like in which part you're working on microgrid part or simple individual solar PV part. Now this is a PV array, right? Now this is a 25 degrees Celsius temperature and 1000 watts irradiations, and this can be varied. Like if there is a partial shading conditions, you can make it 200, 500, 800 based upon your choice. Now the output of this will be given to the buck converter, like in the previous videos I've already shown you. And VPV and IPPV is the input of buck converter, and you already know the buck converter configuration, that is the switch, the diode and the inductor. Here I'm using the extra part that is our capacitor, that is the input capacitor. Output capacitor is already there. This actually basically used to filter out. That's why I'm using this as input capacitor. The derivation of these inductor and capacitor you can easily find out in the reference books. I'll mention on my website also in the description below. You'll find the link for calculations and everything. And now what happened here is I'm using the incremental conductance maximum power point to give the pulse to this switch so that it should operate at maximum power point. Now here it will just generate the output voltage and output current that will be fed to the resistive load, right? We're going to change in this load in future. Now what happened here is I want to just visualize maximum power point. Now I'll just open it. Here what happened here, I'm taking input voltage and input current, input voltage and input current of buck converter, or we can call it an output voltage and output current of solar PV. Now if I double click the incremental conductance, I'll get the incremental conductance maximum power point tracking algorithm, which I have written. In a similar fashion I have written this, like D initial is 0.5, D maximum it can go up to 0.8, D minimum is 0.1 and delta D is 0.01, means it will increase by 0.01, right? Now I'll just open it and I'll run this. Now this I've already told you that is a zero order hold, and this will generate my duty directly. In the previous video I've shown you the duty it is generating, and then we are implementing the duty to pulse generator. In the similar way, this is also generating the same, because the maximum power point algorithm will give me the duty. If we just see the formulas for calculation of incremental conductance maximum power point, it always gives me the duty, right? So basically, if you want to just see how maximum power point is working, I'll just give you a small example. So this is a 25 degrees Celsius and this is a maximum power point curve. So what happened is when you run your algorithm, when you run your simulation, it will start from this. It will increase by 0.01, 0.01, 0.01. It will increase. It will search whether it's a maximum power point. It is not a maximum power point. Then it will try to oscillate in this range. It will go, then it will check that maximum power point has already been left behind. Then it will go back. And similar fashion, it will just oscillate in this point, like this. So here is a maximum power point and then this oscillation will come. That's why we are getting the 3 pulse waveform during the maximum power point, or we can call it at steady state, right? So that's all, and I will run this simulation now. And this is one of the basic thing that we need to use a power GUI block, that is a discrete. That is very basic for this. Yeah, its simulation is running. Now I will just visualize my, this is my steady state. Yeah, this is all steady state. You can just see it has reached to the maximum power point, that is 301. We have already shown you that 301, and this is the current and this is the voltage, and this is my duty, which is becoming 3 pulse, like it is being oscillating here like this. See this, like this, like this. So in this fashion we are getting the maximum power point. Now there are various types of algorithm already available in literature. Except perturb and observe incremental conductance, I have used some modified technique also. So that thing also we are going to explore in the upcoming videos. Hope to see you in the next video. Bye bye.